The de Broglie wavelength is given as h by p or h by mv, or in terms of energy, h by root 2 m e. So this neutron, which has thermal energy kBt, has a de Broglie wavelength of, let's say, lambda n, h by root 2 m, Boltzmann constant, and the temperature. The electron, there is another electron. This electron is in the third orbit and is revolving in a Bohr's orbit of an atom, which is hydrogen-like, but with z number of nuclear charge, z number of protons. So we know something from classical mechanics. Let's try to derive this relation. The nucleus is positive protons and there is one electron, and it is revolving in the third orbit. So we know that the force, the Coulomb force, will be F equals K ZE E by R squared. K Z E squared by R squared. And this is the force that is keeping the electron in the orbit. So this is the centripetal force which is keeping the electron in the orbit, which is mv squared by r. Now we get a relation from here. Let's bring it in terms of r. So k z e squared by r mv squared. R equals k z e squared by mv squared. Now Bohr gave a postulate saying that the angular momentum of an electron is the integral multiple of h by 2 pi, and in this case n equals 3, which means mvr equals 3h by 2 pi. mv is the linear momentum, 3h by 2 pi r. So the de Broglie wavelength of this electron, let's say this, is h by p, and we got p value, which is h by 3h by 2 pi r, 2 pi r by 3. Now we need to substitute the value of r from here. R we have got in terms of v. So using the Bohr's relation and the equation from classical physics, we can do one thing. We can represent the let's eliminate something. mvr equals 3h by 2 pi, which means let's get v 3h by 2 pi r. Now let's substitute this v squared into this relation, which will give us 9h squared 4 pi squared r squared, k z e squared by m v squared, which is 9h squared by 4 pi squared r squared. Now let's bring this in terms of r, which means the r will be equal to 9mh squared, and this goes to the denominator, giving us k z e squared 4 pi squared. This is r. Now we also know that okay, well, we started with n equals 3, but we need to bring in the Bohr radius of hydrogen atom, which is r for n equals 1. So in order to bring that in, let's get the general expression for this V. So the general expression for the V is nh by 2 pi r. So this will give us V squared n squared h squared by 4 pi squared r squared. So let's just substitute this into this part, which will give us r k z e squared by m v squared, which is n squared h squared 4 pi squared r squared. Let's bring this in terms of r, which will be r, giving us m n squared h squared, and divided by kz e squared 4 pi square. Now for n equals 1 and z equals 1, this will be the electron in the hydrogen atom, and this will be the ground state of the hydrogen atom, and r will be the Bohr's radius. And in the question they use a naught. When you plug in n equals 1 and z equals 1, we get a naught equals m, which is mass of electron, h squared by k e squared 4 pi squared. Now this value we need to bring it in here. Okay, let's write the general radius in terms of n squared by z, and this is the Bohr's radius. So this is the radius, the general expression for radius, and the reason we are doing all of this is that we want to express this de Broglie wavelength of this electron, which is 2 pi r by 3, and here r is, okay, we can use this part. We can use this expression saying for n equals 3 and z, r will be 3 squared, which is 9 a naught by z. So 2 pi 9 a naught by z, and this is the de Broglie wavelength of the electron, this is the de Broglie wavelength of the neutron, to be precise. This is the mass of neutron and this is the mass of, okay, this is the electron. Now it is given that these two are equal, which means h by root 2mn kbt equals 2 pi 9 a naught by 3z. We need to isolate t. Okay. 3zh by 2 pi 9 a naught will be equal to square root of 2mn kbt. 3 square 9, z square h square by 4 pi square 9 a naught. 9 squared a naught squared will be 2mn kbt, and 9 so t will be z squared h squared by 4 pi squared 9 a naught squared z square h square 4 pi square 9 a naught squared by 2 mn kb. Okay, so this expression now looks like the expression given in the question. T equals z square h square by pi squared a naught squared mn and kb. All the other numbers are together alpha, so alpha will be 4 times 9 times 2, which will be 72.